In this lesson, we'll practice more of the abstraction concept we've discussed. This time, we'll build on our light simulation by synchronizing some of the light switches. Navigate to this URL to get started. Once you see this page, fork the project to get your own editable copy. To do this, click on the project name in the top left to get a dropdown. Click on the ellipses to get another dropdown. And finally, click on the fork button. Then, I suggest placing your Skillshare and REPL.it windows side by side as shown here. Before we begin, I want to introduce a new concept you haven't seen yet, a default argument in Python. Let's start by defining a subtraction function. As a reminder, here is the format for defining a function. For once, this format slide is actually the exact code we'll write. Let's write our code now. Your code on the right-hand side should match mine. If you scroll down, you'll see the light class that we defined in previous lessons. Right above this light class, we're going to define the sub method that we see on the left-hand side. Go ahead and type out define sub parentheses x comma y and return x minus y. Let's now use the subtraction function. We'll call sub with inputs 7 and 4. Go ahead and hit the green arrow at the very top to run your code. Then type in sub 7 comma 4 to get 3. Now what happens if you forget the second argument? What if we type sub 7 and hit enter? Well, you'll get an error, and your error will look like this. It tells you that you're missing your second argument. So let's define another subtraction function, sub2. This time, we will assign y a default argument of 0. Let's write our code now. We'll define sub2 x, but now we type y equal to 0, and everything else remains the same. This equal sign in the function definition gives y a default value. It doesn't always assign y to 0. The function only assigns y to 0 if you don't give a second input argument. Let's see this in action. First, run the file by hitting the green arrow at the very top. Let's see what happens when we pass both arguments like before. Type in sub2 7 comma 4, and as expected, we get 3. Here, x is assigned to 7 and y is assigned to 4. Now let's see what happens if we only pass in one argument. Type in sub2 7, and turns out there is no error, and we get 7 out. So what happened here? This is because x was assigned to 7, and y was automatically assigned to 0, so we got 7 minus 0. Let's now cover a related concept called keyword arguments. This is best explained by example. Let's rerun the previous version with two input numbers. Here we'll have sub2 7 comma 4. Here, 7 is assigned to x, and the second input 4 is assigned to y. You hit enter, we get 7 minus 4, which is 3. We can also explicitly tell Python which input is x and which input is y. Here we can type in sub2 x equals 7 and y is equal to 4. We can hit enter and we still get 3. We call these x equals to 7, y is equal to 4 keyword arguments. You can specify keyword arguments in any order. Here, we can switch the x and the y keyword arguments. Sub2, y is equal to 4, x is equal to 7. Hit enter, and you still get 3. Notice that if you don't use keyword arguments, and you switch the inputs, then you'll get something different. I'm going to clear my output so that you can see the bottom of my screen. And here, we're going to type in sub2 4 comma 7, switching the order without using keyword arguments. And here, the output is different. We get -3 because we now have 4 minus 7 instead of 7 minus 4. Now that you've covered default arguments and keyword arguments, let's use them in our new class. We're now going to finally work on the abstraction concept. We're going to add the ability to synchronize two lights so that toggling light number 1 also toggles light number 2. Go ahead and scroll to your light class. We'll add an argument to the constructor called sync. This argument will have a default value of none with a capital N. None just means empty. The intention is to set sync to another light to synchronize with. You'll see what I mean in a second. Here we're going to define right after the self argument, comma, sync equals to none. We can then set the input argument sync as an instance attribute, also called sync. So here we'll write self.sync equals to sync. Let's now use this sync attribute. If it isn't empty, or in other words, if the sync attribute is not none, then toggle the synced light. So go ahead and scroll down to your toggle method. Here we're going to type in if self.sync is not none, then toggle the synced light. Here, you could be tempted to simply toggle the synced light yourself, by writing in self.sync.on equals to not self.sync.on. However, you'd be breaking abstraction. What if that light is synced with another light? Then we'd have to check if self.sync.sync is not none, and so on and so forth. And whoa, that's redundant code. So like always, redundant code is a big red flag. Instead, we have to respect abstraction. Self.sync is a light, and we can toggle lights by calling their toggle method. So instead, we'll write self.sync.toggle. This concludes our synchronized lights. Now, we're going to instantiate and use the synchronized light. Go ahead and hit the green arrow at the very top to run your code. And now let's instantiate our very first light. Light 1 is equal to light. Instantiate your second light, but this time, set the sync input argument to the first light. This ensures that if we toggle light number 2, light number 1 also toggles. So here define light number 2 is equal to light, set sync equal to the first light. Let's see if light number 1 is on. We're going to type in light1.isOn. It looks like our first light is not on. Now let's toggle light number 2. This should toggle both light number 1 and light number 2 on. So here we have light2.toggle. And let's check that light number 1 is now on. Light number 1 is on. And it's now on. Great, it works. For a copy of these slides and the finished code for this lesson, make sure to check out the course website. This concludes our additional abstraction practice.